Up until now, our relationship with AI has been strictly conversational. You type a prompt, wait for a few seconds, and the machine generates an answer. It sits idle until you ask it to do something. But the demonstrations at Google I/O 2026 suggest a shift in how this software actually functions. We are moving away from passive responders towards systems that run continuously in the background, making decisions without waiting for a human to initiate the next step. Google showcased this through Gemini Spark and their Antigravity platform. These tools operate as autonomous agents that stay active 24/7. Even with your devices turned off, the software can spend the night auditing code bases, managing financial documents, or executing multi-day workflows. By delegating our digital tasks to these background processes, we are effectively removing the confirm button from our daily operations. The AI is no longer just suggesting an action, it is taking it. This level of autonomy introduces a high-stakes risk. If an autonomous agent hallucinates a fact, it doesn't just produce a wrong sentence, it executes a wrong action, potentially deleting the wrong database or authorizing an erratic payment. To mitigate this, developers rely on a logic layer called Retrieval Augmented Generation, or RAG. This process is designed to anchor the AI's reasoning in verified data before it executes a command. In the retrieval phase, the agent bypasses the open internet, scanning a closed database of proprietary information to identify exact technical documents. During generation, it combines this verified data with its core logic, ensuring the final output is based entirely on the provided corpus. RAG provides a necessary verification layer for the software, but it doesn't eliminate the physical cost of autonomy. An agent that never stops processing places a massive continuous load on the hardware infrastructure that keeps it alive. To support millions of these concurrent autonomous tasks, we must look past the abstract cloud and down into the physical reality of the server room. India has become the primary geographic focal point for this massive expansion of physical compute capacity. Corporate commitments are reflecting this scale, notably with Amazon's CEO Andy Jassy announcing a $48 billion investment to expand India's cloud and AI infrastructure by 2030. This software doesn't exist in the ether. It is a physical force requiring unprecedented amounts of copper cabling, industrial cooling systems, and raw electricity to function. To provide the necessary power, companies like AirTrunk are committing $30 billion to build 5 gigawatts of data center capacity across India, roughly the energy output of several large nuclear reactors. Connecting these hubs requires a global network of subsea cables. Google is currently investing $15 billion into this undersea connectivity to ensure data moves between regions with minimal latency. This hardware ensures that when an autonomous agent triggers a task in London, it can process the request instantaneously through a server in Mumbai and return the result before the user even notices. This $100 billion web of steel and silicon is only as reliable as the code that manages it. If the underlying algorithms are compromised or opaque, the entire global infrastructure supporting our digital lives becomes an exposed, high-value target. As these agents take on more complex roles, their decision-making processes are becoming increasingly difficult to interpret, often operating as black boxes, where the specific path to a conclusion is hidden. This lack of transparency has triggered aggressive regulatory pushback. Under the European Union's Digital Services Act, prosecutors are now demanding that companies prove their algorithms are free from bias and fraudulent data extraction. X provided a pivotal case study when it announced it would open source its entire recommendation algorithm, including the code for advertising, in response to intense regulatory pressure. While open sourcing a production-scale algorithm solves the immediate problem of political transparency, it creates a new challenge for security teams. The exact logic running the platform is now visible to anyone looking for a way to exploit it. The primary risk is the security of the software supply chain. Estimates suggest that 86% of codebases already contain vulnerabilities inherited from the open source components they are built upon. When exposed, threat actors map the dependency tree, looking for a single unpatched flaw in a third-party library to grant full system access. Security researchers race to find these flaws first, hunting for manipulatable biases, hard-coded credentials, and data patterns that violate privacy laws. The transition toward autonomous systems is currently built on a foundation of Google's logic and massive industrial builds in India. But the speed of this shift is now limited by a single factor: whether we can actually audit and secure the code making these decisions on our behalf.